done, do the same questions again in the class we did then, another few questions in the tutorial provided today. Okay, that's enough. But some different types of questions I supposed to discuss in paper class and in special paper discussion class, right? Okay. Last week, of course, we discussed the graph of e to power x exponential function. Exponential function we define like this: y equals ex, where this ex is called as the exponential x, right? Right, exponential x, right, or exponential function y equals ex. So this ex we define like this: ex is equal to 1 plus x upon 1 factorial, x squared over 2 factorial, x cube over 3 factorial, and like this this goes to infinity. Actually this is called as infinite series. Okay, now here the factorial mean, for instance, if I take 3 factorial means starting from 3 up to 1 with all positive integers we multiply. First, starting from 3, we write all integers up to 1. Starting from 3, right, we write all positive integers up to 1 and we multiply them. This is the value of 3 factorial. And the other thing is, when we write 1 factorial, it is obviously 1, and people remember we define this way 0 factorial. You might think 0 factorial mean 0 or something else, right? No, 0 factorial we define to be 1. Okay, this is a definition. 0 factorial is 1. Okay, right. Right, in the last time lesson we said the value of E is approximately 2.71. The value of E is an irrational number. The approximate value only we can give for this E, right? And the graph of Ex we drew, right? The graph of Ex we drew, it was like this, no? Is the x-axis, y-axis, graph of Ex is this. The graph cuts the y-axis at 1 here, right? 0, 1 point is this. This is a graph of y equals Ex. Here you can see this graph, Ex graph, actually when it goes to negative infinity direction of x, that means when we actually keep drawing this graph negative side, the graph coming closer to this x-axis. Graph coming closer to the x-axis means from the x-axis to this graph, that height is decreasing. That height only we define as y. So this graph touches this x-axis at negative infinity. Understand? But we know we can't find negative infinity. So that says the graph does not touch this negative x-axis. That means this height always, there is a gap between the graph and the x-axis. That gap is called as the y value of the graph. That means this. It is always what? Positive, because the graph is above the x-axis. That means when we move from negative infinity up to positive infinity along x-axis, when we move, always the graph is above the x-axis. That means y is always positive. So therefore, for any value of x here, there we can put for this x any real number from negative infinity up to positive infinity. For any value of x, this Ex means y, no? This Ex is therefore positive. Okay, that note also we discussed, right? Today we are supposed to draw as the first part the graph of y equals, right, e to power minus x graph. This is the first graph today. Then some limits we have discussed under this Ex, then we can come to the derivative part, right. So, then today write down the first one is the graph of y equals e to power minus 6. The graph of y equals e to power minus 6. The graph of y equals e to the power minus 6. Okay, here also we must find the same points last time we used to draw the graph of y equals e to power x. Y equals e to power minus 6 really I can write like this, taking this minus 6 power, here it is at the numerator, no, I bring this to denominator, then this power becomes plus 6, understand, right. So, then we get this one I can write as this way. Okay. Then we find these points. First one, when x equals 0, right? Put in x equals 0 here, find y value, right? Secondly, find when x limit goes to plus infinity, what happened to y? Find this. Okay. Third point we need here is when x goes to negative infinity, find y. These things are enough for us to draw this graph of y equals e to the power minus 6, right. First find those points. Right, first one is when x equals 0. When x equals 0, for x 0, 1 over e to power 0. E to power 0 is 1, no? This is 1, right? So, then y equals 1 over 1, y equals 1. What is meant by this? When x coordinate is 0, y coordinate is 1. That means the graph passes through 0, 1. Okay? Right. Therefore, graph passes through 0, 1. Okay? 0, 1. Secondly, people take number 2, when x going to plus infinity, the corresponding y value. To find this, what I do is this, I take limit x going to plus infinity of this e to power minus 6, no? E to power minus 6 only I wrote as 1 over e to power x, right? So, then I write that here, 1 over e to power x, right. This means x going to plus infinity means this x will be equal to plus infinity, right. So, then we will put directly there 1 over e to power infinity, right. You know people, e means 2.71 here, e is 2.71, assume that as just 2 to the power infinity, what do you get? Infinity, no, huge value, no. Then 1 over e to the power infinity is infinity, 1 over infinity is the fraction going to 0, understand, okay, right. So, then we get what? This is 1 over now infinity, this is this says y going to what? 0. 1 divided by huge value means answer is 0, y limit going to 0. Right. Now, Next one, number 3, take value of y as limit x going to negative infinity. Right. It is 1 over e to power x, right? Okay. Now we will put that here. Okay. Y equals 1 over e to power, for this x here we put minus infinity, right? Now this e to power minus infinity we can take to numerator as what? E to power plus infinity. Okay. Now suppose e 2.71 to the power infinity. What happens? We get huge value. It is infinity, no? It is infinity, right? So then this says y goes to plus infinity. This way. Now this data is very much enough to draw the graph of y equals e to the power minus 6, right? Okay. Now we will draw the graph. Graph passes through 0, 1 here. Right. First, this data if I take here, x going to plus infinity means we move along the x axis this way here. Then what happens to y? Y comes to 0. Right. That means what? When we go along the x axis, positive x axis towards plus infinity direction, the y coordinate of the graph coming to 0. That means what? The graph coming closer to x axis, no? Then only the y value, y coordinate becomes 0. Okay? Right. And here, x going to negative infinity. That means what? We must move along negative x axis to the left like this. While we are moving towards left on the negative x axis, y should go to plus infinity. Y going to plus infinity means what? The y coordinate of the graph should be increasing through positive values towards plus infinity. That means what? As we move along the negative x axis to left, the gap between negative x axis and the graph should be increasing. Okay, then by considering these all facts, of course, we can now draw the graph. It should be like this, no? Right. It should, the graph should pass through the 0, 1 point like this. This way we must get the graph. Okay, don't draw the graph so that it touches the x axis like this. It touches the x axis at positive infinity. Okay, so this is the y equals ex graph. Y equals e to the power minus x graph is this, right? This is how we do that graph. This lesson is a very easy lesson. Every year a question is coming of 150 marks, and this application part of this lesson is very useful in most of the lessons in applied maths and pure maths. And this lesson is used everywhere in higher studies, not only in mathematics, agriculture, medicine, economics, right? Everywhere this lesson is used, right? So then in this case we discuss really very fundamental concepts of differentiation, right? So this is another huge area, right? Okay, construct this graph. y equals e to the power minus x, right. Right, now finish now, hurry up. We are supposed to find another one limit involving this Ex, right. Thereafter the limit part will be over, we can come to the differentiation part, right. Okay, no? Yes. Now write the next subheading like this. Right now, write down this as a subheading to find limit x going to 0 e to the power x minus 1 divided by x. Right. E to the power x minus 1 divided by x, right. Now, in finding a limit, our first attempt is what? In finding limit, our first try is that x value here 0, no? We first substitute for this x and this x, and we see whether we get a meaningful answer. If it is one of the indeterminate form, then only we should go for an alternative method. Okay, that's the thing. First, that x value under limit available, we substitute for every x in the function. If the resulting answer is indeterminate form, meaningless form, undefined form, then we should go for an alternative method. Now, once we put here x equals 0, here we get e to the power 0 minus 1 divided by 0. You know, e to the power 0 is 1, no? Power 0 of any number is 1 other than 0 to the power 0. This is 1, 1 minus 1 divided by 0. 1 minus 1 is 0, 0 divided by 0 we get. This is undefined form, no? Yes. So, therefore, directly put in 0 for x, we won't get the answer. Then let us see how to take this way. First, I am writing the definition of Ex. What is the definition of Ex? Ex we define this way, no? 1 plus x over 1 factorial, x squared over 2 factorial, x cube over 3 factorial, x4 over 4 factorial, and so on. This goes to infinity. Okay, right. Now, I take this 1 to this side, left hand side, then we get what? E to the power x minus 1. Now, once we take this 1 to left hand side, from here to infinity, all the terms available on the right hand side. X upon 1 factorial, right? X squared over 2 factorial, x cube over 3 factorial, x4 over 4 factorial, and so on. This goes to infinity, right? Now, people like divide both sides by x. Once you divide both sides by x, in the left hand side we get e to the power x minus 1 divided by x. Now, on the right hand side, every term we should divide by x. See what happens there. When this is divided by x, this x and the device x will cancel and give into numerator 1, right? 1 divided by 1 factorial, 1 factorial also 1, 1 divided by 1 is 1, okay, right. This is 1 now, right, after dividing by x. Once this x squared divided by x means this becomes x, no? X over 2 factorial, I will keep that as 2 factorial. and this one should be what? X squared over what? 3 factorial. Okay, this will be x to power 3 over 4 factorial. Now you can very clearly notice, according to this pattern, after this term up to the last term, in every term at the numerator there should be x later. Is it clear? No? Yes, right. That's very obvious thing. Now what I do is, I take the limit x going to 0 in the left hand side, then right hand side both. Understand? Then we get the answer. Right. Then we will start first. Write down. Right. We take limit x going to 0 on left and right. This way we have some dots, right? That says there are infinitely many terms, and every term contains at the numerator x later with more powers. Right. I took limit x going to 0 in the left and right. Okay, now people, I take limit x going to 0 in the left and right. Then I keep the left hand side without changing. We need to find that. What I do next is, people, on the right hand side, for every term, x containing in the term, we put what? 0. Okay, right. Then what we get is limit x going to 0 e to power x minus 1 over x. Now the first term doesn't contain x to put this 0, therefore that one change. No x, no, in that, yes. The rest terms and the numerator we have x. Then when we put 0 for x, right, you know any power of 0 will be 0. Then in the rest terms, every term numerator become 0. Right? Here when you put 0, 0 squared is 0. We told in the next terms also the x letter available. When you put 0, the numerator of the next terms also 0. Right? Yes. Right? So this way we get up to infinity. So you know when the numerator of fraction is 0, the whole fraction 0. Then after this one, the rest ones all 0. Okay? Correct? No? Then really we get what? Only 1 on the right hand side. Okay, right. So therefore, remember, the earlier when you directly put 0 for every x, we got undefined form, but really its value is what? 1. Okay, right. So then we can write it as limit x going to 0 e to power x minus 1 divided by x. This is 1. It is 1, right? No? So, this limit you can directly use wherever you need to take an answer of a question, right? Right, okay. Right, we will now first of all identify the function here involving this e to apply this limit as 1. Here e to the power x, this power should be x, right. After that minus 1 we should have, and whole thing should be divided by the same power x. That x should go to 0, then only for whole thing you can put what? 1. Okay. Now, in other words, suppose here we have e, here we have girl, right, then fill the rest, e to power girl, minus 1 divided by what? Girl, girl, and here girl should go to 0, no? Yes, and this girl should go to 0 under limit. Then this whole thing should be equal to what? What? තේරුණාද? මෙයාම මෙතන ඉන්න ඕනේ. එයාම 0 වලට යන්න ඕනේ. And then this whole thing is what? 1. Okay? So therefore, using this fact, we can really prove in place of this x, in place of this x, that we write down as a note. Yes. Where f(x) is a function in x or function of x, also correct. Function of x means an expression involving x, right. We'll count some questions and later we can go to the next part. Okay, we'll take down these questions. First question is this. Limit x goes to 0 e to power 2x minus 1 divided by x. Number, yes. This is really according to our order of the numbering under the questions, should be 22nd question, I think. 21 number of questions we did in the class in the last time, I think. See whether it is 21st question we did, no? Last time on the limits. Yes or no? How many questions we have done under limits? Yeah, this is 22nd, no? They will write. This else 22nd. Uh, 23rd question is this. Limit x going to 0 e to power sin x minus 1 over x. 24th question is this. Limit x tends to 0 x times e to power x minus 1 over 1 minus cos 2x. These are the questions. Under this we are supposed to discuss. Right, no? Write down these 3 questions. That is the end of the limits. Right. Okay, the first one will take 22nd one. Right. Limit x going to 0 minus 1 over x. Can we directly apply that theorem? No. We told what? When we have something, the same thing here we must have, same thing should go to 0. Otherwise, we can't directly apply the theorem. Understand? We told no. When we have here girl, same girl should be here, same girl should go to 0. Boy also possible to put at these places. Okay? But here we have 2x, here we have x. Here must be 2x. Understood? Otherwise we can't. And this not x, 2x should go to 0. Then in according to the theorem, we must now form this. Then this is how I form it. First I write this numerator e to power 2x minus 1. Here we must have 2x, no? Then I write x, and that means what? The given expression we have divided by 2. The given expression then changes, no? Can we change like that and we can do? No, we can't. So therefore we have to keep the given function, given expression, to remove that effect, we multiply this by 2, correct? No? Then these 2 and these 2 will cancel. Right. And people, that's okay now at the moment. Now other thing is, this 2x should go to 0. You know, when x going to 0, any multiple of x also going to 0, that we already know. When x going to 0, any multiple of x going to 0. Is it clear? Yes. So therefore, this x going to 0, I can write as x going to 0, 2 times x also going to 0. As x going to 0, 2 times x also going to 0 parallel to itself. Yes or no? Yes. So therefore, it's very obvious as x going to 0, 2x also going to 0. Right. Now see whether we have obtained that required form to apply the theorem. Yes, now we have. What is that? E to power something we have, girl 2x now. The same girl here we have, now girl going to 0. Now for this whole thing we can put what? 1. Okay. Now 2 into 1 is therefore what? Now the answer is 2. This is how we take. Yes. Right, now start. Right now. Next one is 23rd. 23rd. Limit x going to 0. E to power sin x minus 1 over x we have here. Right. I divide this by 2 and meantime multiply by 2, it won't change. Just dividing by 2 can we keep? No, then the given question we have changed and our question now we are doing, no marks, wrong answers. Yes. Right. People here, see whether this is according to the requirement of our theorem to apply directly? No. If sin x is the girl, not that girl here. We must have here not x, we must have what? Sin x. Okay, in order to apply the result. Then we'll prepare like that. This way I suppose to do it now. Here e to power sin x minus 1 we write. Right. People, now here this x I write later, I write here sin x. We must have only x. Then next to this I write sin x here and x here. See whether I have changed this given expression. Have I changed that on right hand side? Have I changed? No. Reason? This sin x will cancel with this sin x, 1 and 1 come in here. This 1 and this x will be x. Then we have e to power sin x minus 1 divided by x. The same thing we have. Yes or no? Yes. Now we must write limit here x going to 0. Here also we write for this product the limit x going to 0 separately. That's also okay. Now people, you know this answer. Sin x upon x as x going to 0, last week we learned. What is this? Sin x upon x as x going to 0. What is that? 1, that is 1. Okay? This is 1. Now see whether we can apply our theorem directly to this. See whether the all requirements are fulfilled by this. Girl here, e to power girl minus 1 divided by girl, that's all. Okay. But x going to 0, what should go to 0? Girl should go to 0, that means sin x should go to 0. If we had sin x going to 0, then we could have used what? That theorem directly. Now how to do this now? People, you know something like this. When you consider the sin x graph, we drew the sin x graph here. Here the x means angle. Here for any angle its sin value given here. You know the sin x graph here. This way we get the graph. From the positive angles, negative angles, this way we get the graph. Now x going to 0 mean, people, we come to this 0 is here, angle 0 is here, we come to this 0 angle from this end and from this end. You can see once we come to this 0 from the right, somewhere here, suppose any angle, its sin value is given by this height. You can see once we come closer to this 0, this height is decreasing. This height means sin x. Then what can you notice there? As x going to 0 means limit x going to 0, no? When we come towards this 0. This height decreases means what? Height means sin x. Height decreases means what? Sin x also going to 0. Is it clear? Therefore, x going to 0 means what? Sin x also going to 0. Understand? That means your father earning more, then more money coming to mother, then more money coming to you, right? So then more money coming to your friends, so on it goes, no? That like that x going to 0 means what? Sin x also going to 0 parallel to itself. So therefore, the next line I can write x going to 0 meantime implies what? Sin x also going to 0. Understand? So then we can replace that sin x going to 0. This is also therefore in accordance with our theorem, and we can apply the theorem now. Okay? Alright. Limit sin x going to 0, e to power sin x minus 1 over sin x. Here now we have 1. Okay? Now this is okay, no? E to power girl minus 1 divided by girl going to 0. It is now 1. Okay. This is also now 1. Therefore, 1 into this 1 means it is 1. The answer is 1. The answer is 1. Take the 24th one. Right, take the 24th one. X times e to power x minus 1 divided by 1 minus cos 2x, no? Right. People first write down this cos 2x. Right, there are 3 formulae for cos 2x, no? In trigonometry we learned. Write down the corresponding formula for cos 2x to cancel down this 1. Then the cos 2x should contain plus 1, no? Because before that we have minus, no? What is the formula 4 cos 2x involving plus 1? 1 minus 2 sin squared x. Write down that and keep simplifying. You will get the idea. Hurry up. Right. One minus 2 sin squared x. Okay, right. Once you remove the bracket by multiplying this minus sign, this 1 becomes minus 1. This minus and this minus make plus 2 sin squared x. Here we cancel down this and this one. Right. Limit x going to 0. X times e to the power x minus 1 divided by 2 sin squared x. This is what we get. Correct, no? Yes. Right. This 2 is a constant. No, this 2 is a constant. Since this 2 is at the denominator, this 2 is really what? Half, no? Half. That half doesn't change though this x going to 0. No? Therefore, we can take half out. Understand? Right. Like this. I take that out. Right. Now, people, I write the next one like this here. X times e to the power x minus 1. Right? Okay. Divide by. This sin squared x, I write like this, 1 over sin squared x. Correct, no? This sin squared x is at the denominator. When something available in the denominator means what? It is a fraction. That fraction is what? 1 over that term. Okay, right. Then people, I write here x squared. Now, so far, right, so far, have we changed the given thing this? No. An equal form only we keep writing so far. Now, what I do is this. I write extra x squared here. Because of this division, the given original expression will change. Can we change like that? No, we can't. Then we have to avoid this change. Tell me the method of avoiding this change. We have to cancel down writing this x squared by another x squared. Tell me the place where we must write this x squared to cancel down this one. I write that pair here. Like this. Right. Now see here. This x squared is, when I produce this line this way, this x squared is above that line. This x squared is below that line. These two we can cancel down. Really, we have this. That means this we have. Clear, no? Now what I do next is this people. Here x and here x squared, 1x I can cancel down. Now this limit x equals 0 we apply for this and this separately. Understand? Then we get the answer. Yes. Limit x going to 0. Here also I put limit x going to 0. Yes. Now what we have there, people, half limit x going to 0 e to the power x minus 1 upon here x. Here we have sin squared x upon x squared. Sin squared x upon x squared we can write as single perfect square. How? Sin x upon x perfect square. Like this. We can write it like this. Sin x upon x perfect square. This way. Okay? Right. Before it we have limit x going to 0. Okay, now people, since this is a perfect square, that limit x going to 0, we can insert into the perfect square like this. This way I can put. This limit x going to 0, it is outside of this. Since this is a perfect square, we can bring inside the perfect square. Okay, like this. Now see what is here. Sin x upon x as x going to 0. What is this? This is 1. 1 square is again 1. That one, what is this? E to power x minus 1 divided by x, x going to 0 is also 1. Alright. So this is what? 1 square. No, this also 1 square means 1. Then what do you have? Half into 1 into 1. 1 over 1 means 1, that is half. Half is half. Understood, right? Yes. Half into 1 into 1 over 1 squared we have there, right? 1 squared is 1. Now that is the answer there of half. Right? No? This is how we take the answer. Okay, this is the end of the limits, people, right? Yeah. Right, now write down that answer and try the questions in the tutorial. Some more sums available in the tutorial. Sometimes you won't be able to take the whole answers for whole questions in the tutorial, doesn't matter. Right, maximum number of questions you should answer. Okay, once you do more sums, the difficult sums you can really manage in the future. Don't worry at the moment that you can't do all the questions, they are difficult, we can't do, we are not at the required standard level, what to do and so on. Don't worry, right? Because that will be okay with the time. Yes. Right, but thing is, as many sums as possible, do as homework yourself, try, people, then only you will get that skill. Without doing or trying, right, you can't improve the skills. Okay. Right, now write down the next subheading like this. Write down the differentiation. The main heading is limits and differentiation. Limits part we finished. Now we come to the differentiation part. Right? Okay. This part is very easy part. I'll first give you the theory. After that we can do the questions. Right, people, now I'll take this way the graph of y equals x squared. Right. You know the graph of y equals x squared. is a minimum graph passing through the origin like this here. This is the graph of y equals x squared. Here y. Okay. People, now I will take x equals 2. Here x coordinate is 2. Right. Can you tell me corresponding y value? Yeah. What is this y value? 4, no? How to find? Put x2 and square, we get y equals 4. Now people, here x value is 2, no? Right. X value is 2. The corresponding y value is 4. Right. Now I increase this x value by a very small value. X value at the moment is 2. I increase my x value 2 by a very small value. S පහකට බලන්න එපා නිදියන්න යන්න හොරින්. කාගේද? පෙන්ඩෝල් එකක් අබමුද? ඕනේ. පෙන්ඩෝල් එක බිව්වනම් හරියයි. ගේන්න ගේමුද? තියෙනවද? බොන්න කියන්නේ නා. Migraine. Okay. People, now I increase my initial x value is 2. I am going to increase this value 2 by a very small value. That very small value is like this here. Right. Too small. Too thick. Right. Now tell me, what is my new x value? Earlier 2, now to that 2 we add this. What is that? Right? 2.3 zeros, another 3 zeros, another 4 zeros, 1. Okay. Now I supposed to mark this new x value on the x axis. It is almost on the same point, no? If I mark so that you can't clearly see this one, I take a considerable gap to show this. I take somewhere here the new x value available. Right? Then this increment is this figure, no? Understand? Earlier x was here 2, it has increased by this value. The new x is here. Okay, right. Now I supposed to find corresponding y value for the new x value. Right. What is the new y value? This. Can you see, compared to the earlier y value and new y value, the y value has also increased by a small value. Understand? Small value. Right? Now without taking this way specific value for x, I take this value as x. What value? This place value as x. Okay? Right. Now if I take that value as x, x equals x, then I write it as therefore x. Then this length only x. Then this x we increase by this very small value. To denote this very small value, we use a notation delta x. Right. Delta x. Delta stands for what? Small x. Right? Delta stands for small x. Delta x, small x. Small x. Small system means delta system. Delta stands for small. Kuda Banda, we can now say how? Delta Banda. Small L, right? Okay. So therefore, this is delta x now. Chuti malli කොහොමද කියන්නේ? චූටි මල්ලි පොඩි මල්ලි කියන්න පුළුවන් කොහොමද? ඩෙල්ටා මල්ලි. ඩෙල්ටා මල්ලි. චූටි නංගි ඩෙල්ටා නංගි. Delta stands for small. Right. So then people, this is the y value, right? Okay, now you can see x has increased by delta x. Now tell me what the new x? X plus delta x. Okay, then what is the increment of x? X initially here, now here x has increased by delta x. This delta x is called as what, people? Increment in x. Increment in x, right? Now you can see, people, once this x increases by delta x, you can see what is this? It is the increment in y. Then tell me a notation to show or say increment of y. Delta y. Delta y. This is delta y. This is delta y. Now tell me what is new y value? Initially y, it has increased by delta y. New y value is y plus delta y. Okay, right. So therefore, this is, people, delta y. This is now delta x. Now we can divide the increment of y, delta y. We can divide by delta x, increment of x. Right. Then we have this delta y upon delta x. Numerator we have what? Increment in y. The increment in y occurred due to what? Increment of x. Understand? First, the variable change was x. Understand? Right. Now this is a ratio. Numerator we have increment in y, denominator we have increment in x. Therefore, this is called as what? Incremental ratio. Incremental ratio. Right? Okay. This is called as incremental ratio. Okay? Now people, we supposed to find this ratio value. Delta y over delta x ratio value we supposed to find taking the increased value delta x let into 0. What do you mean by this? We supposed to find delta y over delta x ratio letting this delta x 0. That means what? This height we divide by this length. By taking this delta x 0 means what? This gap we reduce little by little this way. Once we reduce this gap, what is this gap? Delta x. The gap from here to here, the gap reducing means what? This delta x is going to 0. Understand? Okay? By reducing this gap, now suppose this delta x I brought up to here. Now you can see the new y, delta y. New increment is this here. New increment is this here. New increment in x is this here. Now we find this ratio. Like that, furthermore we decrease our delta x. We bring this delta x up to here. Now new delta x is this. Now find the new increment in y. It is this. This we divide by this. Right? Like that, reducing this delta x little by little towards 0, we find this ratio. Understand? One occasion we get a certain value for this expression. That value we denote by this way, dy over dx. Understand? Dy over dx. Don't worry how to evaluate this. We will evaluate that later. Don't worry. By using the limits idea, we can evaluate that. This dy over dx is called as, people, derivative. The derivative of y with respect to x. Why do we use this with respect to x? with respect to x means people, first we change our x by delta x. Accordingly, we notice there is a change in y. First we change x by delta x. That is why with respect to x word we use. That is one. Secondly, we denote this dy by dx as what? Differential coefficient of y with respect to x. Differential coefficient. Differential coefficient of y w dot r dot t x. What is this w dot r dot t? With respect to x. Understand the other names, right? Now people, let's see how to find that dy over dx for this example, right? I will take like this. Carefully listen to me. Thereafter I can give you the definition, right? First one is this. I will take here when x is x, what is this y? Given by what? Here x square, no? How do you find the y value when x code is 2? We put that 2 here, no? Then we find y. Now what is our x value? X. Then where do we put x? For this x, right? Then what is corresponding y? X square, no? Then first thing is when x equals x, y is given by x squared, number 1. What is new x? After increasing by delta x, x plus delta x, right? Yes. Now we need to find the new y. How to find? New x we have to substitute where? Here, right? Then we get new y. We take new y as what? Y plus delta y. Understood? Y plus delta y. Okay? Then new y we take as y plus delta y, no? Then this place is y plus delta y. Then new y is found how? The new x we have to put here. This way. Right? Number 2. We need what? Dy by dx. To find dy by dx, first we need what? Delta y over delta x. What is that? Incremental ratio we need. For that, first of all, we will find delta y. How to find delta y? Take 2 minus 1. Here, y plus delta y minus y. What happens? We get delta y. Right? Delta y. On the right hand side, what do you have? X plus delta x perfect square minus x square. Delta y, this is okay now. But we need what? Delta y over delta x. How to form delta y over delta x? Divide left and right by delta x. Okay? Right. We divide left and right by delta x. This way. X plus delta x perfect squared minus x squared over delta x. Right. Now incremental ratio we found. Now to find dy by dx, what we need to do is we have to take limit delta x 0. No? Then what we do? In the left and right we take what? Limit delta x 0. Okay? Right. Now I take next line I write this way. Limit delta x going to 0. Delta y over delta x only we need to find, right? Now I take limit delta x 0 on the right hand side as well, this way. X plus delta x perfect squared minus x squared upon delta x, right? People, for this only we said we put the notation what? Delta y over delta x. What is that? Incremental ratio. Its denominator delta x going to 0. For that only we told we put what? Dy over dx. What is that? Derivative of y with respect to x, or differential coefficient of y with respect to x. Then I can put here people dy over dx. Now its answer is given by right hand side. Now you must use your great knowledge. අති විශේෂිත දැනුම පාවිච්චි කරන්න පුළුවන් දැන් ඔයගොල්ලන්ට ලිමිට්ස් පිළිබඳව තියෙන. How to evaluate this now? This is a limit question now on the right hand side. That's why we learned limit before going to differentiation. Now what we do? We just Directly put delta x 0. What will happen? Here 0 means within bracket x squared minus x squared will be 0, numerator 0. Delta x equal to 0 means denominator also 0. We get 0 by 0. Undefined form. இப்போ என்ன செய்யுது சொல்லுங்க. We know this kind of situation, before putting delta x 0, we must have cancelled down delta x from numerator and denominator. Can you remember I told you? For that people, we expand this right hand side brackets. Right? Tell me here, this is like a plus b perfect square. Tell me the expansion. A squared x squared plus 2 into x into delta x. And what is next? Delta x perfect square minus x squared. Okay, divided by delta x. Now people, sometimes you might think to multiply this x and x in the delta x. You can't. Delta x stands for what? Very small value of x. Can you separate that into delta and x as a product? Delta x, can you write this as delta into x? No, never. චූටි නංගි වෙන් කරන්න පුළුවන්ද? චූටි නංගි කියලා දෙන්නෙකුට පුළුවන්? පුළුවන්. චූටි නංගි වෙන් කරන චූටි නංගි කියලා. පුළුවන්ද? බෑ, දෙන්නම එක්කෙනෙක්. හැමදාම එක්කෙනා. චූටි නංගිමයි නේද? Right. Alright people, therefore delta x we can't write like this. And the other thing is people, this one, delta x squared. Delta x squared people, sometimes you might think to simplify delta squared x squared. This also you can't do. Delta x squared is what? Small thing perfect squared. Forever same. Evali under bed. Right. Okay, the concept is very important, huh? Right? Okay. Now people, you can cancel down here x squared with this x squared. Right. Right. Now see what we have. Limit delta x equal to 0. Right. People, now you can see here we have delta x, here we have delta x squared. What is delta x squared? Delta x into delta x, no? Then from numerator we can take delta out, no? 2x plus delta x squared we write as delta x into delta x. We told that we are going to take one delta x out, no? Then here we have one delta x out and we divide by delta x. These two you can cancel down. See here. Right, no? Then see what you have. Okay. Left hand side we have dy over dx. Right. We have limit delta x going to 0, people 2x plus delta x. Here we have a sum. To this sum we apply this delta x 0 separately for this and this, like this. Dy over dx. Limit delta x going to 0, this is 2x plus, right, next one, limit delta x going to 0, delta x. Right. People, it is well obvious, here we have delta x. That delta x here going to 0. This one, this says going to 0. Then tell me what is the answer of this term? 0, no? Here we have delta x. This says it is going to 0. Then this place will be what? 0. Right. Now, tell me this answer. Here we have 2x. Delta x going to 0. Yes, you know this 2 is a constant. 2 is a constant. එහා ගෙදර කට්ටිය රණ්ඩු වෙනවා. අපිට ප්‍රශ්නයක්ද? No. Delta x going to 0. 2 is forever the same, no? It's a constant. Can you change that 2 by letting delta x 0? no. ඔයාගේ පරම පියුතුරු ආදරය තව දෙන්නෙක් රණ්ඩුනා කියලා වෙනස් කරන්න පුළුවන්ද? නෑ. Forever fixed. Two we can take before people. Two is a constant. That is why we can take it. Now x only there we have. Now tell me people, what happened to this x as delta x equals 0? 0. Delta x going to 0. Here we have x. What happened to these people? Come to the diagram. Come to diagram. People, what was your x? The distance from here to here. X. Right? The x means the distance from here to here. Show me your delta x. Delta x, the gap is no. Starting from here up to here, the gap is delta x. This is delta x. This is going to 0 means what? This gap is decreasing, no? When delta x 0, where it terminates, where it stopped, exactly here that will stop, no? Still x doesn't change. Understood? Therefore x doesn't change even though delta x goes 0. This is x itself. Then this is x. Then what is that, people? 2x. Left hand side what do you have? Dy over dx. What is the derivative? 2x. Understand? Okay. Right? This is how people we find the derivative for a given function. This method is called as the first principle method of finding dy by dx. Now let's see how to do this. How to define this, right? Now people, I took here a specific function y no as x squared. To give this definition commonly, without taking this way a specific function, I will take here this as fx. Then what is this fx? Any expression involving x. Earlier it was x squared. For our convenience we took. Now using this, will define this. Okay? Alright. Now write down a definition of the derivative as a subheading there. Definition of the derivative. Definition of the derivative. Definition of the derivative. Right. Right, like this. Let's consider the function y equals fx. Right? Instead of early x squared, since we need to define that derivative for all cases which is common, we take the right hand side function as fx. Correct, no? Right. Consider the function y equals fx. We'll come to small diagram there. I erase this one. Right. Now keep this memory in your mind to compare with the steps I supposed to write after this. Right. This way I take the graph. I will take graph of that like this. The y equals fx. Right. Okay. First row graph. Small graph. Right. Draw the small graph. Okay, mark this. This is a small value delta x, right? The corresponding new point on the graph I take as q. This is q now, new point, huh? New point has new y value. It has new x value. New x value we already know, x plus delta x. New y value is y plus delta y here. This increment of y is delta y, right? Mark this. Right, no? Yes. People now, first complete this, clearly do the diagram, right? You have to take the graph like this, increasing graph like this, huh? Draw diagram, clear diagram. Right. Draw a clear diagram, huh? Right. ගොඩාක් චූටිව අඳින්න එපා. චූටිවට ආස ඇති. ගොඩාක් චූටිව තෝරගන්නත් එපා. නේද? Too small graph now here in the book. Huh? Too small graph. இந்த பாருங்க. Too small. Right. It is sufficient. Should be sufficient that you can take this form. Huh? Right. People now, first we write like this. Right. Now, imagine the first example I took. Y equals x squared. No, this way. I took x here, and I told you this is y. The equation is y equals x squared. Right. In order to find this height y, this x coordinate we substitute where here, no? Right. Now people, in this case, I took x coordinate as x and I took y coordinate as y, this one. Then to find this y, where do we substitute this x? On the right hand side, for x we have to put x, no? Right. But here we don't have an expression form, it is notation form. To give the idea that we need this fx value when x equals x, where do we substitute that x? For this place of x I have to put. Then earlier we obtained y equals x squared as first equation, you can remember we obtained as this equation. Now tell me what equation we get? Y equals fx again. Is it clear? The same thing here we got, no? Alright. Now we write first thing like this. Write down. Consider a point capital P, within bracket write down x comma y. Consider a point capital P, within bracket x comma y on the graph of y equals fx, on the graph of y equals fx. Therefore, we may write y equals fx, this is number 1. Okay, this is number 1. Write down like this. Let us increase simple x, let us increase simple x by a very small value, by a very small value, by a very small value delta x, right, delta x. People, some occasion, some people they use this way, the next delta, the delta, this way, but I use this one, right? Okay, this is also possible to write, this delta, simple and capital delta, no, right? So I use this one, right? So when you write delta, people, don't write it as 8, right? Don't close here. This is the delta, delta x, delta x. Right on. Then the new x value is, the new x value is x plus delta x within bracket, x plus delta x. Write down now. Due to the increment, delta x of x, due to the increment delta x of x, y also increases, by a very small value, let this value be, let this value be, let this value be delta y, write down. Then the new y value is, within bracket write down y plus delta y, Right, now people tell me how to obtain the relationship between x plus delta x and y plus delta y. This new y value is y plus delta y, that we can obtain the new x value x plus delta x, put in where? Here, no? Can remember there? In the earlier case we did? Yes, write down. Therefore, we may write, y plus delta y is a new y value. What should be the right hand side? Yes? On the right hand side of this equation, every x we must replace by x plus delta x. How to give that as a notation? This x replaced by x plus delta x. Right, like this. F x plus delta x. This notation, remember people, whatever on the right hand side we have, it's every x we must replace by what? X plus delta x. That's the meaning. Number 2. Right. Now what we need to find next? We need to find increment in y, no? Yes. How to find that? We take 2 minus 1. Write down. The increment of y the increment delta y of y, write down like that. The increment delta y of y can be found by 2 minus 1. Okay. Then what do you get there, people? Y plus delta y minus y. Y and y we can cancel down, we get delta y. No? Right. Delta y. Tell me right hand side, if x plus delta x minus fx. Correct, no? Now, before going to find dy by dx, what we need to find next? We need the incremental ratio. What is that? Increment in y divided by increment in x. What is that? Delta y over delta x. To get that, we divide both sides by what? Delta x. Okay? Now divide this by delta x, both sides. Okay, what is the name we assign for this delta y upon delta x? No. This is called as incremental ratio. Dy by dx is coming later. Take in limit delta x 0, right? Right on here. Delta y over delta x is known as incremental ratio. Incremental ratio. Okay, right. What is the next step? To find dy by dx, we need what? Limit delta x 0 of this. Since this and this being equal, we have to take limit delta x 0 in the left and right, both. Okay. Now write down. Now, let's take limit delta x 0 on both sides. Right, like this. Right. For this only we give what? That notation. What is that? Here limit delta x going to 0, incremental ratio delta y over delta x is called as what? Dy by dx. What is this dy by dx? Dy by dx. What is the first one? Derivative of y with respect to x. Number 2, differential coefficient of y with respect to x. Understand? Right. Number 1, the derivative of y with respect to x. Second one, the differential coefficient of y with respect to x. W dot R dot T means theta, relative to x means the idea that. Okay. Now we can write what people, for this place we can put what? Dy over dx. Understand? Right. Then we can write, therefore dy over dx is equal to what? Limit delta x going to 0. This is the formula to find dy over dx. Okay? Yes. Remember this formula, right? Limit delta x going to 0, fx plus delta x minus fx divided by delta x is dy over dx. People, for this right hand side also we have another notation. Why do we use usual notation, right? Why do we use notation? Notation means, in order to give the whole thing at once, the short form is the notation. No? Right? Sometimes suppose there is a well popular girl, suppose the name is very long, we put a nickname, X girl. Everybody knows now, notation is X. එහෙම නේද? ඕගොල්ලෝ දාන්නේ එක එක ඒවා නිසා nickname දාන්නේ. ඒ දාන්න ලේසියට නේ. හැමෝම දන්නවා මේක කිව්වම අරක තමයි බඩුව කියලා. For this also people there's a notation. The notation is f dash x. Right. Note that f dash x is this. Limit delta x going to 0, fx plus delta x minus fx divided by delta x. This f dash x is called as what? Derivative of fx with respect to x. Okay, right. Write down that also. And f dash x is called as the derivative of fx with respect to x, with respect to x. Okay, right. Now people, you have to remember this. For a given function, if you need to find dy over dx, first derivative of y with respect to x, or differential coefficient of y with respect to x, what should we do? What is this? The given function right hand side, we must replace every x by what? X plus delta x. What is this? The same given function. That difference we have divided by delta x. Then we have to take limit delta x going to 0. Then we have to evaluate that limiting value. That is the dy over dx. Is it clear? Not clear. I'll take one example. Right? You completed writing this all. Right. People, this is what I am trying to tell you. Right. Suppose this way, we are given y equals x minus 1 divided by x plus 1. This thing only people you fix now, right? Right. Now tell me how to write dy over dx. Dy over dx. Limit delta x going to 0. Open a bracket. Inside the bracket we have a fraction. What is the denominator? Delta x. What is first one? This right hand side fx, this no, it contains x here and here. Every x you must replace by what? X plus delta x. Yes. Here this x we write as x plus delta x minus 1 divided by this x also x plus delta x plus 1. Right. That is this first place over there we have fx plus delta x minus fx means the same thing. Right. Right? That's all. Whatever this given function, this one how to obtain? Replacing its x by what? X plus delta x minus same thing divided by what? Delta x, and its limit we take as delta x going to 0. Then we use our great knowledge of limit. Now you can manage limit questions ni. ඔයගොල්ලන්ගේ අති විශිෂ්ට limit knowledge එක use කරලා මේක හොයනවා. Then the final answer going to be dy by dx. Is it clear? Set උනාද? set වෙලා ඉන්නේ. ෂෝක්. කොහොමද? Right. We'll take few examples. Right. Okay, write down one first question like this. Using first principle, find dy over dx of y equals x squared. First principle means using this definition. Right? We have to always remember this definition. Right? That formula remember. What are the formula, people? dy over dx equals limit delta x going to 0. What is inside the bracket? Numerator. What is numerator? F x plus delta x minus fx over delta x. Right. Now you know what is this? That can be obtained in the given function right hand side. Every x you have replaced by what? X plus delta x minus fx, the same thing. Okay. Now put and keep simplify. Right. Right hand side this x we replaced by x plus delta x perfect squared minus same x squared divided by delta x. Now expand this using a plus b squared. X plus delta x perfect squared means it's like a plus b squared, no? A squared, that means x squared. 2ab, 2 times x times delta x. Next one, delta x perfect squared, right? Delta x perfect squared. Here remember this x and this x in delta x we can't multiply. We can't separate this delta x as how? Delta separately and x separately as delta into x. No, delta x together stands for small value of x. So therefore x into delta x forever x into delta x. Okay, right. And this delta x squared you can't write as what? Delta squared and x squared. Delta x is a single thing. When delta and x both together only, there will be the meaning small value of x. We can't therefore separate. Then delta x squared forever, delta x whole thing perfect squared, right? Minus x squared here we have here. And here delta x. Now we have in hand only a limit question. As delta x going 0, if we need to evaluate something, we know from numerator and denominator we have to definitely cancel down delta x before put in 0 for delta x. That until you do that step, don't put 0 for delta x, you get undefined form. Now first we can cancel down people this x squared with this minus x squared. Then here delta x and 1 delta x here we can take out. I will write another one more step there for easy understanding. 2x plus here 1 delta x we take out from a bracket like this, divide by delta x like this, cancel down this 2. Now we have to put this limit delta x 0 here and here separately, right? That also I suppose write like this, 2x plus limit delta x 0, right, delta x. This 2 is a constant, you can take that out, right? The next questions of course don't need to write this all steps, right? So this is the very first time, that's why I write them. Take these 2 out because 2 is a constant, nobody can change the place of 2 on the number line by letting something 0 or going to infinity or whatever. 2 never change, that's forever fixed. That's the meaning of constant, right? Yes, right. So now I can write the next line, take these 2 before. Right, to limit delta x going to 0, here we have x, but this is obviously we have delta x that only going to 0, then this place will be 0, no? Correct, no? Here we have delta x, this says it is going to 0, then this term will be 0. Yes, right. What is this now? X, it won't change. You can think it like this. You have in your pocket 1000 rupees, right? Your brother gave you another 10 rupees by coins, 1 rupee coins. From time to time, the brother takes the given 10 rupees, 1 rupee each. Right, initially you had 1000, brother gave 10 rupees, 1010 rupees now. The given amount, brother given amount, he takes 1 rupee each. Gradually that given amount decreasing. He takes only given amount. after taking fully his given amount, still you have what? Your initial amount. Like that, x increased by delta x, that increased value now going to 0. The initial x still available there, x doesn't change because of letting delta x 0. Understood? Therefore, this one change, though this delta x went 0. Right? ඇයි අපි දොයිය මත? බබා නිදිය ගත්තේ නැහැ. කොයි බබාද? චුටි බබාද මහා බබාද? Right. Here people we have 2x. Okay. Now we have dy by dx. Therefore, people dy over dx is what? 2x. Right. This is the answer. But really remember, we write this one in another way too. People, what is this y? Y means the initial function x squared. For the place of y, we can put x squared, then we can write this in another way. Right. Also, you can write it like this: d over dx. Here, this y I write as x squared equals 2x. This also we write. People, now this y is the initial function. Then read the rest. This d stands for what? Differentiate. What? Y. With respect to x stands for this dx. You know, this dx is coming with respect to x coming because of what? Initially, we changed the x by delta x. Later we observed what is the increment in y. Initially we change x by delta x. That is why we say this as, right, with respect to x. Later we do, first we increase y, then we find the change in x. Then what could be this? Derivative of x with respect to y. Understand? So therefore, this d upon dx, this is like a command. This is like a command, right? Now, for example, when somebody says you, what do you do? It's a command. You see, you stop your all talking. We finger point like this. Don't talk, stop there. Like that, people, this is that command, d over dx. This is a command. Right, this command we give people to a function here involving x. Then what do you mean by that? This function we have differentiate with respect to x. Right? Therefore, this d over dx is called as differential operator. Operator. Understand? Differential operator. What do you mean by that? When we assign that d over dx operator, it says the next function here we have should be differentiated with respect to x. Understand? Right? We will come to that later. Right? That is operator. So, for example, another one take like this. Here you have 10 to the power 3. We write before this log 10. Now, what you do to this 10 to the power 3? We find a logarithm of 10 to the power 3 subject base 10. So, this log 10 means what? Certain operator. Once we apply that one, it undergoes, the number undergoes with this operator. Like that, people, d upon dx operator we apply for a function. It means what? This function should be differentiated with respect to x by using this way. Therefore, d upon dx is called as what? Differential operator. Understand? Yes. Write down this also like that. Right. Shall we take another one question before taking the break? Let's see. Another 5 minutes more we have. Right. Right. Now take the next one. This. Y equals 1 upon x. Find dy by dx. Y equals 1 upon x. Y equals 1 upon x. Take. What is our fx? 1 over x now. Right. Find dy by dx. Apply directly this. பிறநாள் இல்லையா எங்களுக்கு? Yes, start here. Right. Apply this method. How do I divide by dx? Limit delta x 1 0 within bracket. What is first one? The right hand side every x must be replaced by x plus delta x. Okay, no? What do you get then? 1 over x plus delta x minus 1 over x divided by delta x. Now we have to evaluate this. What is the answer? Good. Right. Now I am supposed to simplify this. Right. This delta x is really, people, 1 over delta x, no? Dividing by delta x means multiplying by 1 over delta x. Okay. Then I take the next part like this. Open another bracket and write down inside bracket like this. Okay. Now simplify this taking common denominator. Remember, people, finally to take the limit value, what should we cancel down? Once you bring this, right, this side delta x minus 0 means delta x, no, we must cancel down delta x. Until then, don't put 0 for delta x, right? We learned that in last time limit techniques, right? Simplify here. Dy over dx is equal to limit delta x over 0 1 over delta x. Here take the product of x plus delta x and x as the common denominator. Then this x comes here, x plus delta x comes here. Right? Now you can see here, once you remove the bracket, here we get minus 6, then this 6 and this minus 6 we can cancel down. There we have minus delta x at the numerator divided by x plus delta x into x, like this. Now we reach to the place where we can cancel down delta x. This delta x now you can cancel down with this, we get 1 here, then the numerator is minus 1. Okay. Now this is the place. After this, I write the next line also. Minus 1 at the numerator, x plus delta x into x we have here. Like this. Now people put 0 for every delta x now. This is the place where we have delta x. We know though delta x going 0, we said what x never change. So therefore, no need to put this delta x limit for this separately and so on. This is enough now. X doesn't change though this delta x going 0 that we saw obviously there in the diagram, right? Now this delta x 0, here only we have delta x, put for that 0, then this bracket becomes x and x is x squared minus 1 over x squared coming as the answer. Yes. This is the answer. So therefore, I can write this as how? D over y equals what? 1 over x squared, or substitute for this y, d over dx 1 upon x is equal to what? Minus 1 over x squared. So then how do you read this? The operator d upon dx, when we apply on the function 1 over x, the answer is what? Minus 1 over x squared. Okay, that's how we understand that notation. Okay, no? Right. Then we will come to break. Okay, then we'll come to the lesson. Yes, people. Right, we'll take another one more question here. Bahal ni, kuare aku. Okay, all right. The next question is this, people. By using the first principle, obtain this y equals root x plus 1. Y equals root x plus 1. Right. Find the dy by dx. Find dy by dx. Using first principle. Right, start. This one. Start by using the first principle. Right. What is dy by dx? Limit delta x going to 0. Right. Here we put delta x. What is the first function? Here. This x replaced by x plus delta x, okay, plus 1 root minus root x plus 1. Okay. Now we have in hand limit question. Can you remember last week we found the limits of this kind of functions? What is the method? Conjugate, we multiply. And finally, before putting delta x 0, we must cancel down delta x from numerator and denominator. After that, put delta x 0 and take the answer. Multiply by the conjugate, no? Numerator and denominator both. Right. Hurry up. Now see how important the limits to take the answers. Right. multiply by the conjugate, this delta x write down as 1 upon delta x. Then write down this, multiply it by the conjugate of that numerator and derivative both. Right, no? Yes. So, the conjugate of this is this plus this, by that I multiplied and divided. Now, you can multiply this two. Then there you have what? This is your A minus B multiplied by A plus B. What is A minus B, A plus B product? A squared minus B squared, right. What is A squared? Square of this. Square of this means, since here we have root sign, root will eliminate, minus square of this. They also root will eliminate, but you must put inside the bracket. Yes. dy over dx. One upon delta x the root will eliminate there, x plus delta x plus 1 minus this. Denominator is that x plus delta x plus 1 plus root x plus 1. Okay. Now, what happens there, people? This plus x will cancel with this minus x, plus 1 will cancel with this minus 1 we get, right. Now, here we have delta x. Okay. Numerator we have delta x now, no? Okay. Others cancelled. That delta x now I cancel down with this delta x. I am not going to write another one step there, right. Okay. Now, we can take the answer like this. So, here delta x, when we cancel down with this delta x, here we get 1, here also we get 1. Now, the next line I write, this is what now we have, limit delta x point 0. Here now we have 1 is divided by this. Now substitute 0 for every delta x, right now. This is the place where we have delta x, only one delta x we have, put here 0. Then we get x, right, plus 0 within bracket now x plus 1 root here. Here also x plus 1 root. Root x plus 1 plus root x plus 1 means what? 2 times root x plus 1, no? Therefore, we get dy over dx 1 over 2 times root x plus 1. Right now, this is how we take that. Right. Okay, no? Right. Now, we will come to theory this way. The derivative of y equals x to the power n. The derivative of y equals x to the power n. Right? Okay. The function is now fx function is x to the power n. Right. It's not. Find dy by dx. Write the definition and take the answer. Okay, right. Now, how to write dy by dx, people? Right, limit delta x going to 0. What is the first thing? This x we replace by x plus delta x to the power n minus the same divided by delta x. This is what we have now. What's the answer? Now, I write it like this here, dy over dx, limit delta x going to 0, I do something like this to the denominator. X plus delta x to the power n minus x to the power n. Here we have plus delta x, no. I add x and subtract x. Does it change? I'll look at the denominator here. Here, x minus x, we can cancel down, no. Plus delta x, this is having there. Neither? මොකත් කරේ නැහැ හිටියා වගේ. Right. Now people, delta x going to 0. Tell me, I am going to take this way something. I have an expression x plus delta x. Tell me what happened to this when delta x going to 0. Just take this expression. What happened to this x plus delta x when its delta x going to 0? Yeah, here. This delta x going to 0. Then what happened to this x plus delta x? It goes to x. Huh? No? Therefore, people, if I say something like this, delta x going to 0 implies x plus delta x limit going to x. Is it correct? Yes or no? Yes. What do you say? Delta x going to 0 implies x plus delta x going to x. In other words, x plus delta x going to x implies delta x going to 0. Correct no? Even එන ළමයි මම මෙතෙන්ට දාන්නද මෙයාම වෙනවා තව විදියකින් නේද? This I can replace by how? X plus delta x limit going to x. Same thing no? අහුණාද? අහුන්නේ නැහැ. අහුවෙන්න දෙයක් නැහැ. චූටි එකක්. චූටි වහුවෙන්නේ නැහැ. මේකයි ළමයි වෙන්නේ. මේ බලන්න. මේ එක්ස්ප්‍රෙෂන් එක x plus delta x තියෙන ළමයි. මෙතෙන්ට 0 ආවොත් මේ ටෝටල් එකට මොකද වෙන්නේ? x වෙනවා නේද? ඒකයි මේ ඉල්ලේ තියෙන්නේ. x plus delta x මෙන්න මෙයා මේ 0 වලට ගියොත්. right? මේ එක්ස්ප්‍රෙෂන් යනවා කාටද? x. right? Then we can say x plus delta x going to x means its delta x going to 0. හිතන්නකෝ සාක්කුවේ 1000ක් තියෙනවා. මල්ලි දුන්නා රුපියල් 10ක්. රුපියල් ඒව 10ක්. දැන් කොච්චරක් තියෙනවද? 1010ක් තියෙනවා. මල්ලි දුන්න 10න් රුපියල ගන්නවා. දැන් මොකද වෙන්නේ? අර 1010 ටික 1000 වලට යනවා. හවුද නැද්ද? අන්න ඒ වගේ තමයි ළමයි මේ x plus delta x කියන කෙනාගේ මේ delta x කියන කෑල්ල යනවා 0 වලට. එතන මෙතන 0 වෙනවා අන්තිමට. දැන් තියෙන්නේ මොකද්ද? x plus 0. නේ? So then I can write this limit delta x going to 0 what? This limit delta x going to 0 we can write how? X plus delta x going to x. අහුණාද? චූටි කෑල්ලක් තියෙන්නේ. ඒක අල්ලගත්තේ නැත්නම් වැඩේ කරගන්න බැහැ. චූටි උන්ට කෑල්ල ප්‍රබලයි. දැන් සෙට් වුණාද? right. හරි. Then we can write it like this. Dy over dx, we can write this as how? X plus delta x going to x. Right? This says delta x going to 0. Now, go to your past memory. Something like this we discussed in the first day under limits. Can somebody give me an answer for this limit? What is the limit of this? Can you remember we did one limit theory like this? Xn minus an divided by x minus a. This x goes to a. මේකේ limit එක මොකක්ද ළමයි? n a to the power n minus 1 නේද? Yes, no? How do you understand this expression? Once you ignore this power and this power, what you get x minus a, that should be at the denominator. I told you. Under limit, this must go to this, that's what I said. Then for such a limit, we told without proof, answer is n a to the power n minus 1. See whether same available here. Once we ignore this power and this power, x plus delta x minus x. Here we have. Under the limit, this should go to this. That's also available here. Now this is very similar to this. නේද? මෙයි මැච් කරගන්න පුළුවන්ද? මැච් කරගත්තා නම් ආන්සර් එකත් මැච් කරලා කියන්න බලන්න. What should be the answer? කියන ළමයි. Here answer is n into a to the power n minus 1. N means this figure that comes here. A is right this figure. What is the power? Subtract 1 from this here. Then using that, tell me here. क्या नाम है? n x to the power n minus 1. Right. මොකද කියන්නේ? නැද්ද? නැත්නම් හරියට කියන්නේ? අල්ලගත්තා. Right. Right. So then, how do you write these people using another way? Substitute for y x to the power n. What is that? N into x to the power n minus 1. Right? Understand? In the theory, this first day we discussed this, right? This n come in before, next to that this come in here, and its power is subtract 1 from this. Yes. Then n dot x dot subtract 1 from this and write the power. Okay. Therefore, people, this theory we apply directly when we differentiate something. How? This way. Same thing we write like this here. Y equals x power n. We got dy by dx. How to take the dy by dx? We have x power. Bring the power before n and write this x. Now, new power of x going to be subtract 1 from the present power. That's how we differentiate it. Understood? Once we apply for this x to the power 5, tell me how to find dy by dx. Bring 5 before x to the power 5 minus 1. Understood? That's how we apply. Right? Okay. First take down this and we'll come to some questions. Right. Write down these questions. Y equals x to the power 5, number 1. Number 2, y equals 1 over x cube. Number 3, y equals x. Using this theory, do and find dy by dx. Tell me first one, right? What is the answer for the first one? Dy over dx. Tell me, people. Bring this 5 before x, and now subtract 1 from the power 5. 5 minus 1. What is the answer? Dy over dx equals 5x to the power 4. Number 2. First, take this x to the power 3 to numerator. Don't use here, because we proved our theory here. X to the power n, its denominator is 1. Then the power of x should be at the numerator to apply this theory. But here, power of x is at the denominator. So therefore, first bring this to numerator. Then it is what? X to the power minus 3. Now only we have the power of x at the numerator, right? Now apply this theory. Yes. What is that then? Dy by dx. Bring this power minus 3 before x. And now what? Subtract 1 from the power. Minus 3 minus 1. What do you get there? Dy over dx equals minus 3 into x to the power minus 4. X to the power minus 4 you can write at the denominator as x to the power plus 4. Correct, no? Yes. Minus 3 upon x to the power 4. Right? Third one. Third one, y equals 6. Apply this. What is the power of x? 1, no? Here, 1. R dy by dx. Bring this 1 before. X 1 minus 1. 1 into x. What is 1 minus 1? 0. Very good. Right. 1 minus 1 is 0. Very good. What is x to the power 0? 1. Right. This is 1. 1 into 1 is 1. Then what is the derivative of x? 1. Dy by dx is 1. Right? Right, now this is how we apply this theory. Okay. Now we will go to next theory. Right, next theory. The derivative of y equals a times fx. A times fx. A is a constant, that means real number. A function fx is multiplied by a constant a fx, right? Where a is a constant. Right? Apply the definition of derivative and take the answer. How to write dy by dx, people? Limit delta x going to 0. Right. What to do first? The right hand side, x available in fx, we write x plus delta x. Remember, a also before that we have, then a must be written before fx. Now x is replaced by x plus delta x. This is what we get. Minus a into fx divided by delta x. People, you know this a is a constant, no? Constant means real number. Can this delta x going to 0 change this simple a? No. A is a number on the real number line. Suppose on the real number we have 10. Can somebody change the place of 10? No, no, no. You should not be here. The people around you is not good. Then come to me. Can you pull on the gain? Number එක නම් ගේන්න බෑ. වෙන කෙනෙක් නම් ගෙන්න ගත්ත හැකි. නේද? Number is forever there. Number is forever there. Nobody can change. Like that, people, this a also a certain real number. Delta x going to 0 can't change this a. Therefore, the effect of delta x going to 0, right, in any way does not what influence this a. Then a you can take out. Why? Delta x going to 0 can't change what a. Then no point of keeping that inside, neither. Right? Then you can take a out because it's a constant. It doesn't change though this delta x going to 0. Okay, a common, take this a out from this limit. Right? This way. People, can somebody tell me brief notation for this? මේකට notation එකක් අපි ඉගෙන ගත්තාද කියන්න බලන්න. What is this? Limit the excluding this a for the rest. We learned something today. What? F dash x. This is one, the f dash x. Correct? No? F dash x stands for what? Derivative of fx. Yes. Then write down that. dy over dx a times f dash x. Okay. Then I am going to write this substitute for this y. What is y? A fx. D upon dx. A times fx equals what? A times f dash x. Let's see how to use this theory. People, now this is how we use this theory. Okay. I first take this way, y equals 10 times x to the power 5 and y equals only x to the power 5. Right. You know how to differentiate this using the previous theory. What is the dy by dx? 5 we bring before x, 5 minus 1. This is the answer, 5x4. No doubt, using previous theory you can do. People, once you consider this and this, can you say a certain different variable there? What is that? Here this x to the power 5, before it we have a constant 10. Understand? Now you can match this with the theory. Y equals afx, we obtain dy by dx as how? Same a, this constant we have to keep at the same. Derivative of fx is f dash x. Okay. Then when a constant and a function as a product, this theory explains how to differentiate that. Constant multiplied by function. If we have a product like that, keep the constant as the same here and multiply that constant by the derivative of the function we have. Then apply that here, dy over dx. Right. 10 is a constant, that 10 and x to the power 5 is multiplied. This x to the power 5 is, people, like here this function fx. This 10 is like your constant here. Then keep that 10 as the same and differentiate this function. X to the power 5, you know how to differentiate. Bring 5 before x, 5 minus 1. Understand? That's what this theory. Bring 5 before x, 5 minus 1. So therefore, people, hereinafter, when you see y equals here constant and something here we have in terms of x, how to differentiate? Dy over dx, keep this constant as the same, then multiply it by what? Derivative of this function. Understand? That's what this theory. Is it clear? Is it clear? අල්ලගත්ත නේද? දර හයියෙන් අල්ල ගන්න ඕනේ. constant එකක් තියෙනවා, function එකක් තියෙනවා, product එකක් විදියට. Sorry. Then how to find dy by dx? Constant we have to keep as the same and multiply by what? The derivative of the function you have. Understand? හයියෙන් අල්ල ගන්න ඕනේ. Okay, right. We'll come to one question there. Write down question like this. Y equals 10x cube, number 1. Y equals 3 over x power 3. Number 3. Y equals half x. Or x by 2, I will write. X by 2. Right. Tell me here. Tell me here. First, write down 3 questions. Dy by dx. See here, constant and a function as a product. Constant and a function as a product. Then what we do? The constant we write as the same. then differentiate the function. Function is x cube. You know how to differentiate x cube. What is the derivative of x cube? 3 comes before, right? And x 3 minus 1. 10 and 3 product 30 x squared, right? Dy over dx. Here, tell me how to take. First, we take this x power 3 to numerator, 3 x power minus 3, because this power of x should be at the numerator to apply that theory. Now, tell me what is dy by dx. Three we have to keep as the same. Bring this minus 3 before, x to power minus 3 minus 1. Here we have product. 3 into minus 3 means, people, here we have product, right? We have to multiply these two. Minus 9 x to power minus 4. We can keep the answer like this, doesn't matter. Or you can bring this to denominator and you can keep the answer. How take this? Y equals x divided by 2. This divide by 2 means what? Multiplying by half, am I correct? X by 2 means what? Half x. Then half is the constant now. Multiplied by a function x. Half we have to keep as the same. What is the derivative of x? 1. Can you remember earlier we did? You know how to take that? Half we have to keep like this. Here power 1, we bring that before, x 1 minus 1. Here x power 0. X power 0 is 1. That one and this half together, half. Right. Okay? Right. Therefore, remember, when we have a product, constant into function, how differentiate? Constant we have to keep as same and differentiate the function. That's all. Right? No? Our next theory, we'll write. Next theory. People, now the next theory is this. Now, people, here, first example we had y equals 10x cube. Now, next theory we suppose discuss only the constant we have like this, no product with the function, only the constant, right, like this y equals 10. Here we have constant multiplied by a function, but now next theory is only the constant. Therefore, next theory is a what? A derivative of a constant, right? Write down like this, derivative, the derivative of y equals c. What is c? C is a constant. Constant means a real number, fixed value. Right. The derivative of y equals c. C is a constant. Where c is a constant. Right. Yes. Now, here we can take the derivative like this. People, can you tell me, if we need to draw this y equals 10 graph, what is this graph? Straight line, yes, like this. X axis here, y axis here. Y equals 10 means a straight line parallel to x axis cutting this y axis at 10, no? Like that, c also is such a constant. Then can you construct the y equals c graph? Yes, that is a graph, straight line parallel to x axis cutting the y axis at c. Okay? Yes. I will draw that like this. This line y equals c is cutting the y axis at c. Here y, this is x axis. These two are parallel. Okay? Now, people, I take x here. Okay. Then what is the corresponding y? This height, no? Corresponding y is what? This height, no? What is the height? C. This is C. Now I increase x by very small value delta x. Now what is new x value? X plus delta x. Tell me what is the increment for y? What is the increment for y? No increment. Reason? The line is parallel to x axis. Delta y is what? 0. Understood? No increment. Why? The graph is parallel to x axis. From there we can take the answer. Right. First draw the diagram there. Still y is C. Draw the diagram there. Now write down like this. Write down like this. Suppose simple x. Suppose simple x. Suppose simple x is increased by, suppose simple x is increased by delta x. Write down, but no increment in y. No increment in y since the graph is parallel to x axis. Since the graph is parallel to x axis. Since the graph is parallel to x axis. Therefore, delta y is 0. What is delta y? Increment in y. You can see no increment, right? Now divide this by delta x. Delta y over delta x equals 0 over delta x. When we divide 0 by something, what is the answer? 0. 0. Delta y over delta x 0. Now to find dy by dx, what should we do? Dy by dx means what? The limiting value of this incremental ratio. Then take limit delta x 0 on both sides. Right. Limit delta x going to 0 on both sides. Delta y over delta x equals limit delta x going to 0 on the right hand side 0. People, what is this? Delta y over delta x, the incremental ratio. It's delta x going to 0. What is this? This is the one we write as what? මේක තමයි ළමයි අපි කොහොමද ලියන්නේ? කියන්නේ dy over dx නේද? අපේ ළමයි කවදාවත් ඉගෙන ගන්න නෑ වගේ ඉන්නේ. මේකට මොකද්ද ළමයි දෙන නොටේෂන් එක? dy over dx. Right, left hand side we have dy by dx. Right. On the right hand side, tell me, here we have 0. Delta x going to 0. Tell me the right hand side answer. ළමයි 0 කාටත් වෙනස් කරන්න පුළුවන්ද? බෑ. කාටත් 0 වෙනස් කරන්න බෑ. delta x 0 ට ගියා කියලා අපි වෙනස් වෙන්නේ නෑ නේද? යාළුවාගේ FAR එක අවුල් ගියා කියලා අපි FAR එක අවුල් කරගන්න ඕනද? නෑ. We are forever constant. Nobody can change us. Like that. 0 is a fixed value. නේද? යා වෙනස් කරන්න බෑ. What's that? Answer 0. Okay. What is y? Y is a constant. Then put y. d over dx constant 0. Then what is the answer? When we differentiate constant, what is the answer? 0. When you differentiate a constant, answer is 0. Right. Right. All right, our next one, the derivative of y equals fx plus gx plus hx. If we need, we can take another one more, 3 enough, right? Right? Sum of 3 functions. How to differentiate? Let's see. Write down this. You can now write where fx comma gx and hx are functions of x, are functions of x, are functions of x. Right. Apply the definition. Apply the definition. Right, dy over dx, what limit? Delta x going to 0. Right. Denominator delta x. What should we write here? Right hand side, every x we have replaced by what? X plus delta x. Minus thereafter same right hand side. No? Right with that. Right with that. නේද? පළවෙනියෙන් ලියන්නේ මොකද්ද? මේක දකුණු පැත්තේ හැම x කෙනාටම ලියනවා x plus delta x. Minus the same right hand side. Right down. First fx plus delta x plus g x plus delta x plus hx plus delta x minus what, people? Minus same right hand side. Put a bracket and write, because before that we have minus sign. Fx plus gx plus hx, like this. Delta x. Right. Now I take this and removing the bracket, this fx I take. What do you get there? Fx plus delta x minus fx. Okay. People, here sometimes you may get the idea, this fx plus delta x can't be multiplied by this x and x, like this to write. No, you can't. ඔක හරියට කියනවා ළමයි. ඕගොල්ලෝ තනි කෙනානේ. ඩ්‍රෙස් එකක් අඳවනවා. හරි? ඒක තමයි මේ තියෙන ළමයි. ඊට පස්සේ මොකද කරන්නේ? අත ගලවනවා. මේ අත ගලවනවා. කකුල් දෙක ගලවලා ඩ්‍රෙස් එකේ කෑල්ල කෑල්ල අඳවනවා. දෙක equalද? Need equal වෙන්නේ. So therefore this is a notation. You can't remove the bracket like this, huh? Understood? Forever that is same. That gives certain what? Message, no? Understood? Right. Then people, I take this and this together. Like this. Fx plus delta x minus fx. Right. This and this I take. G x plus delta x minus gx. This and this I take. Long expression is coming. This way we have. Right? People, the whole thing should be divided by delta x, no? Then that I can do like this. This I divide by delta x separately. This I divide by delta x separately. This I divide by delta x separately. This is what we have now. Then I can write the within bracket like this. Before it we have limit delta x going to 0, left hand side we have dy over dx, right. Now this limit delta x going to 0, I can apply for this separately. See what you get there. Apply this limit delta x going to 0 for this, and for this separately, and see what you get there. Yes, dy over dx. right? Now tell me. Yes. ළමයි දැන් මට කියන්නකෝ answers දකුණු පැත්තට. dy by dx equals, what is this? F dash x, isn't it? Near the, what is this? G dash x. What is G dash x? Derivative of gx. What is this? H dash x. H dash x. Derivative of hx. Yes. F dash x, G dash x, H dash x. Yes. Then the result I can write like this. Our y, this was what? Fx plus gx plus hx, no? We put that and write result like this. Therefore, d over dx, fx plus gx plus hx equals what? F dash x plus g dash x plus h dash x. This is that result. That means what? If your given function is as a sum, how to differentiate? Each function separately differentiate and add them up. That's what this says. I take one example like this. I take like this. Y equals x cube, x squared plus 6, like this here. Here your fx is x cube, gx is x squared, hx is x. Now we need to find dy by dx. Tell me how to find dy by dx. First differentiate this, plus, differentiate this, plus, differentiate this. That's what this theory says us. When we have sum like this, each function we have to differentiate. Right. Tell me x cube derivative. 3 comes before x, 3 minus 1. What is that? 3x squared. Right. Derivative of this x cube, 3x squared. Bring this 3 before, 3x squared. X squared derivative how? 2x to the power 1, that means 2x. What is the derivative of x? 1. Derivative of x is 1. Understood? It is 1. Derivative of x is what? 1 root. Yes. Right. Another one. If we have like in this sum 10 functions, still the same thing we can apply. Understand? Okay, I will come another one. Our second question is under this theory. X to the power 4, 2x cube, 3x plus 5. Right. How to find dy by dx? X power 4, what is the derivative? What is the derivative of x power 4? Sure. Yeah, how to find x power 4? Derivative of x power 4. Put 4 before x and subtract 1 from this. 4x to the power 3. 4x3. Right. How to differentiate this? Now here you have what? Constant multiplied by a function. We proved one theory today. Constant into function, when we need to differentiate, what we do to the constant? We keep as the same. Right? Here 2 is a constant, function is x cube. They are as a product. We told what? We keep this constant as the same and only differentiate what? X cube. Right, this way. 2 x cube derivative. Tell me. 3 comes before x, 3 minus 1. Right. Tell me here. Here also what? Constant and function as a product. Keep the constant as the same. Differentiate x. What is the derivative of x? 1. 3 into 1. Plus derivative of 5. 0. We told what? When a constant is alone. No multiplication with the function, no. 5 is alone, constant is alone. When the constant is alone, what is the derivative? 0. Right. 0. This is the answer. When the constant is 0 alone, derivative is 0. When a constant is multiplied with the function, how differentiate? Keep the constant as the same and only the function we have differentiate. Yes. Right. We get what? 4x cube, 3 and 6x squared plus 3. This whole. This whole. Right. Next one. First complete this. Right. Now write down next the derivative of y equals ex, exponential x, its derivative. Right. Write down dy by dx by using definition. Hurry up. Y equals ex. Write down the definition. Write down definition. Dy by dx. Limit delta x equal to 0. Here we have delta x. Okay. Tell me the first function. In the right hand side, this x we replace by what? X plus delta x. Okay. Minus same, no? Same ex. Same function. Yes. Ax. Alright. Now we have to evaluate this. Lamai. Then delta x kelima dano 0 kila. Asai nan dan. Dhala balan. Asai. by I. Podung papum delta x 0 here. This is 0. Ex coming minus Ex difference 0. Delta x going 0, therefore this also 0. We get 0 divided by 0. Allah the carbon. 0 by 0 is undefined. Then don't put 0 directly for the delta x. Yeah, we write it like this. Limit delta x 0. People, this e to power x plus delta x we write like this, e to power x, e to power delta x. What do you say? If somebody says no, then explain. E to power x plus delta x I write like this. Am I correct? Yes or no? No? People, 2 to the power x plus y, can't we write this 2 to the power x into 2 to the power y? Can't we write like this? Bases are equal, when they are multiplied, exponential we can add, no? Then like that, no? E to the power x plus delta x, we can write e to the power x into e to the power delta x. We can write, no? Yes. It's like this here, 2 to the power x into 2 to the power y. Right, no? Now this e to the power x is common, take out from a bracket, yes. E to the power x is common, take that out from a bracket. Right? Okay. Dy over dx, limit delta x going to 0, take Ex out. Here Ex is common here. E to the power delta x minus 1. Divided by delta x. This way. Now, you know, going delta x 0 doesn't anyway impact to x. What do you say? Going delta x 0 doesn't anyway impact to x. You agree with me? Delta x going 0 doesn't impact to x. Am I correct? සාක්කුවේ 1000ක් තිබිලා මලයා දානවා 10ක්. දාපු 10 ගන්නවා ළමයි. තිබ්බ 1000 තියෙනවනේ. මොකද කියන්නේ නැද්ද? X increased by delta x. New x is x plus delta x. That increased delta x now going to 0. Still the initial x remains the same. It doesn't change though delta x going to 0. People, if x doesn't change, this doesn't change, Ex doesn't change, though this delta x going to 0. In this case, delta x going to 0, therefore x doesn't change, therefore e to the power x doesn't change, therefore Ex we can take out because delta x going to 0 doesn't in fact to change what e to the power x. Then e to the power x in this case behave as a constant. Why? Delta x only going to 0. Delta x going to 0 doesn't change what? X. Understood? You can take Ex out. Right. Take Ex out lamai. Limit delta x 0. Right. E to power delta x minus 1 divided by delta x. This is what we have. Now tell me an answer for this. ළමයි මේකට කියමු answer එකක්. මෙහෙමලු ප්‍රශ්නය ඇහුවොත් එහෙම. Epidia. No, epidia, right? This is 1. In the morning we learn this as what 1, no? Huh? E to the power girl minus 1 divided by girl going to 0. Sorry, 1. It is 1. Huh? Epidia. Right, this is 1 people. Ex into 1 we get. Right. What do you get? Dy by dx means Ex into 1 means again Ex. That means what? When we differentiate Ex, what? The same thing coming again. The same thing coming again. Therefore, we can write what? D over dx. Y is what? Ex, no? Head in. Y equals Ex. Once we differentiate Ex, we get the same Ex. It doesn't change. This is the only function after differentiating as the derivative, the same function coming. Ex derivative is Ex, remember. Right. Right. Right, no? The result should be in your memory next day, right? Next day I finish what the most of the theories. After next week I start the coupling process. In coupling process also 2 days of theories. There are 2 lessons, morning before break and after break I discuss until they come to the end. Coupling process lesson. That's very important lesson in applied maths. Right. We'll take another one more theory. Okay. We have another 15 minutes. Right. Why? We told the class is over at 12:30. Right. Okay. Right. Now write down next one. Subheading write down derivative of trigonometric functions. Derivative of trigonometric functions. Write down derivative of trigonometric functions, subheading, derivative of trigonometric functions, derivative of trigonometric functions. First one, write down y equals sin x. Right, first one y equals sin x. Write down. Write down the derivative for this sin x using the definition. Y equals sin x. dy over dx. Limit delta x going to 0. Right. Open the bracket. Here delta x. What is the first function? The right hand side x we have replaced by x plus delta x. Sin x plus delta x minus the same right hand side function sin x. Right. This only we evaluate. So do we directly put delta x 0? And no need to check, we get undefined form. දාන්න දෙයක් නැහැ ළමයි. දැම්මහම එන්නේ undefined form එක. නේද? Now we have to go for an alternative method. People, now the next line, this x plus delta x is an angle. I take this angle as C. This I take as D. Then you can see numerator you have what? Sin C minus sin D. Now use your great knowledge of trigonometry. What is sin C minus sin D formula? Give balan. Ko kanta pakshan give sin C minus sin D. What is sin C minus sin D? 2 cos C plus D by 2 sin sin c minus sin d. sin c minus sin d 2 cos దాని కట్ ఇగలి గతనే వගේ నేను దెమ్మ గන්නవను c plus d by 2 and cos d minus c. ඔව් d minus c නෙවෙයි නම් c minus d. ඕවලා මතක ළමයි මතක තියෙන්න ඕනේ. අන්දස් මං කියනවා පිහියක්. තේරුණා? ඒකලා ඔක්කොගේම කපාගෙන යනවා. ඔව්. ඕගොල්ලෝත් එහෙමයි. ෆෝමියුලා මතක තියෙන්න ඕනේ. මේක වැඩේ කරන්න බෑනේ. right? ඔව් මේක මේ කරන්න බෑ. රිසර්ච් පෙන්නන්න පුළුවන් දොහම. sin c minus sin d. right? 2 cos c plus d by 2 sin what? c minus d by 2. Okay, apply that way here. Keep this delta x how? As 1 over delta x. Go through the formula, right? Otherwise, we can't do this. dy over dx. Limit delta x going 0. 1 upon delta x. Right. Apply here. 2 cos. First add this and this angle. Right? Finish? At these two angles, x plus delta x and x we add and divide by 2. What do you get there? X and x 2x, that we have divided by 2, we get x. And this delta x also we have divided by 2, no? Then we get what? X plus delta x by 2 as our c plus d by 2. Okay, right. Now my second part, sin. Right? Take the difference. This minus this. X plus delta x minus 6. X and this x cancel, we get only delta x, and that should be divided by 2, no? Delta x by 2. Write down the formula in a piece of paper and bring that to the class if you can't remember them. Right? Okay. Otherwise, we can't do wedding, no? This wedding. මේ මඟුල කරන්න බෑ. නේද? right? දැන් ළමයි okay, this product we should divide by delta x. Then do we need to divide this all the terms by this delta x? So only one term of them by delta x. Only one term, because here we have product, no? 2 multiplied by cos multiplied by sin, no? That product only we must divide by delta x. Then only one term, any term of these 3 we can divide by delta x. That is sufficient. Okay. Then I do it like this. Left hand side we have dy over dx. Right. I write this cos x plus delta x by 2. Right? And here sin delta x by 2. Now by this delta x I divide this term, then I write that delta x here. Right, no? Okay? Right. People, now another 2, this 2 I must write. I write, don't write now, look at this. I write that 2. Now everything here we have written. This delta x, by this delta x I divided this, that is sufficient. Now I do something like this here. I write 2 here. To cancel down this 2 I write 2 here. Is it okay? I write below this delta x 2 and I multiply by 2, this and this 2 will cancel, that is as at the beginning. Mulling hitiya wage. Now this 2 and this 2 you can cancel down. Understand? Then we can write it like this now. Understood that? අල්ලගත්තද? කාටද අහුන්නේ නැත්තේ? චූටි එකක් තියෙන්නේ. චූටිව අහුවෙන්නේ නැහැ. I must write 2 here, but 2 this 2. Here we didn't have any 2. I divide this by 2 and multiply by 2. This 2 will cancel as at the beginning. This 2 we cancel down people with this 2 now. Still the same. Right. Deny this and this. Okay. Now we have limit delta x 0. That I apply for this separately and this separately. Right. Limit delta x 0. Here limit delta x 0. Right. This delta x by 2 is a single angle. Now tell me answer. Once this delta x goes to 0, this is 0. 0 by 2, this is 0. Then this gives us what? Only cos x. Cos x, yes. Give me an answer for this. This. What answer? Now delta x going 0 mean delta x by 2 also going 0, no? Am I correct? Not there? Delta x going 0 means what? Delta x by 2 also going 0, no? Then I can write here delta x by 2, no? Right? As delta x going 0, delta x by 2 also going 0. Yes or no? Oh. Then lamai මේක දිහා බලන්නකො හොරෙන්. Put for delta x by 2 theta. This is theta down. Sin theta divided by theta. Here theta going 0. අයියෝ. මේක නේද ළමයි මෙතන තියෙන්නේ? What is this? Sin theta or theta, theta going 0 is what? 1. This is 1. This is 1 ළමයි. 1. Then what is this? Cos x into 1 is cos x. Yes. Okay. Then what is dy by dx? Cos x. ඇයි අපි ඔළුවේ අත තිය ගන්න කල්පනා කරන්නේ? අහුන්නේ? ළමයි what is y? Sin x, no? Then what do you get? Derivative of sin x with respect to x is what? Cos x. Right. This way people, for all 6 trigonometric ratios we have to find the derivative. These results are very important, right? Next day we continue from here. The people who absent, ask them to at least take the notes and come to the class, otherwise they can't understand anything in the next day in the class. Right, okay. Right now, so therefore the derivative of sin x is what? Cos x. Like that, if possible, do the derivative of cos x, tan x, sec x, cosec x, cot x as the homework. And bring the result. Next day we will see whether your answers coming here. Right. Okay, then we come to the end of the today class.